stem cells, the building blocks of life itself. But what if these microscopic marvels could actually regenerate entire organs or cure diseases we once thought incurable?
Whoa, that's a pretty bold claim. Are we really that close to using stem cells for such groundbreaking treatments?
Well, that's exactly what we're diving into today. Stem cell research has come a long way in recent years, and the potential applications are truly mind-boggling. Did you know that scientists have already used stem cells to create miniature organs in the lab?
Mini organs? That sounds like something out of a sci-fi movie. How does that even work?
It's pretty incredible, right? These organoids, as they're called, are grown from stem cells and can mimic the structure and function of real organs. Researchers have created everything from mini brains to mini guts. But before we get too far into the futuristic stuff, let's start with the basics. What exactly are stem cells?
Good question. At their core, stem cells are like the body's raw materials. They have two key properties. They can divide and replicate themselves over long periods, and they're unspecialized cells that can develop into other, more specialized cell types.
Exactly. It's like they're blank slates that can be programmed to become whatever the body needs. And get this, every single one of us started out as a small cluster of stem cells. From those initial cells, our entire bodies developed with all their complex systems and specialized functions.
That's mind-blowing when you think about it. So, do we only have stem cells when we're embryos, or do we keep them throughout our lives?
Great question. While embryonic stem cells have the greatest potential they can become any cell type in the body, we actually retain several types of stem cells into adulthood. These are called adult stem cells or somatic stem cells.
Oh, interesting. So what's the difference between embryonic and adult stem cells? And where are these adult stem cells found in our bodies?
Well, embryonic stem cells are derived from early-stage embryos and are pluripotent, meaning they have unlimited potential to become any cell type. Adult stem cells, on the other hand, are found in various tissues throughout the body and are more limited in what they can become. They're typically multipotent, meaning they can differentiate into multiple but not all cell types.
Gotcha. So adult stem cells are like the body's maintenance crew, ready to repair and replace damaged cells as needed.
That's a great analogy. Adult stem cells play a crucial role in maintaining and repairing tissues throughout our lives. For example, the stem cells in our bone marrow are constantly producing new blood cells to replace old ones, and stem cells in our skin help to heal wounds and regenerate our outer layer of skin every few weeks.
Fascinating. But if we have these repair mechanisms built in, why can't we regenerate entire limbs like some animals can? I've always been amazed by how salamanders can regrow their tails.
Now that's a question that's puzzled scientists for years. While it's true that some animals, like salamanders, can regenerate entire limbs or even parts of their hearts, mammals like us have much more limited regenerative abilities. It's not entirely clear why, but it likely has to do with the complexity of our tissues and the way our immune systems work.
That makes sense. I imagine regrowing an entire human arm would be a lot more complicated than regenerating a salamander's tail. But that hasn't stopped scientists from trying to harness the power of stem cells for medical treatments, right?
Absolutely not. In fact, stem cell research is one of the most exciting and rapidly advancing fields in medicine today. Scientists are exploring ways to use stem cells to treat a wide range of diseases and injuries, from heart disease and diabetes to spinal cord injuries and neurodegenerative disorders.
Wow, that sounds incredibly promising. Are there any treatments that are already available to patients?
Yes, there are. One of the most well-established stem cell treatments is bone marrow transplantation, which has been used for decades to treat blood cancers like leukemia and lymphoma. Essentially, healthy stem cells from a donor's bone marrow are transplanted into a patient to replace their diseased blood-forming cells.
Oh, I've heard of bone marrow transplants, but I never realized that was a form of stem cell therapy. Are there any other treatments currently in use?
Absolutely. There are several other FDA-approved stem cell treatments. For example, stem cells are being used to treat certain types of corneal injuries, helping to restore vision in some patients. There are also stem cell treatments for some types of cartilage injuries and for a rare condition called graft versus host disease.
That's incredible. It really does sound like stem cells have the potential to revolutionize medicine. But I know there's also been a lot of controversy surrounding stem cell research. What's that all about?
You're right. Stem cell research has been a hot button issue for many years. The main controversy centers around embryonic stem cell research. Because these cells are derived from early stage embryos, some people have ethical concerns about their use.
I can see how that would be a sensitive topic. Are there alternatives to using embryonic stem cells?
Yes, and that's where a lot of recent research has been focused. Scientists have developed methods to create what are called induced pluripotent stem cells, or iPSCs. These are adult cells that have been reprogrammed to behave like embryonic stem cells.
Whoa, that sounds like something out of a sci-fi movie. How does that work?
It is pretty sci-fi, isn't it? Basically, scientists introduce specific genes into adult cells like skin cells, for example, that cause them to revert to a stem cell-like state. These iPSCs can then be coaxed to develop into various cell types, just like embryonic stem cells.
That's fascinating. Are there any advantages to using iPSCs over embryonic stem cells?
Absolutely. For one, it avoids the ethical issues associated with embryonic stem cells. It also opens up the possibility of creating patient-specific stem cells, which could be used for personalized treatments without the risk of immune rejection.
Sounds promising, but I imagine there must be some challenges too, right?
You're spot on. While iPSCs are incredibly promising, there are still some hurdles to overcome. The reprogramming process isn't perfect, and there are concerns about the stability and safety of iPSCs. There's also the challenge of efficiently directing these cells to become the specific cell types needed for treatment.
I see. It sounds like there's still a lot of work to be done in this field, but it's exciting to think about the potential. Are there any particularly promising areas of stem cell research that you think our listeners should keep an eye on?
Oh, absolutely. One area that's generating a lot of buzz is the use of stem cells to create organoids, those miniature, simplified versions of organs that we mentioned earlier. These are being used to study disease processes and test new drugs. Another exciting area is regenerative medicine, where scientists are exploring ways to use stem cells to repair or replace damaged tissues and organs.
That sounds like it could be life-changing for so many people. Are we close to seeing these kinds of treatments become a reality?
Well, it's hard to say exactly when these treatments will be widely available. Science, especially when it comes to clinical applications, tends to move slowly to ensure safety and efficacy. Many of these potential treatments are still in the early stages of clinical trials. But the field is advancing rapidly, and new breakthroughs are happening all the time.
It's amazing to think about how far we've come in our understanding of stem cells and how much potential they hold for the future of medicine. Before we wrap up, do you have any final thoughts on stem cells that you'd like to share with our listeners?
I think the main thing to remember is that while stem cell research holds incredible promise, it's also a complex field with many challenges still to overcome. It's important to approach news about stem cell breakthroughs with a balance of excitement and healthy skepticism. And of course, always consult with medical professionals about any stem cell treatments.
Great advice. Well, there you have it, folks. We've taken a deep dive into the world of stem cells from their basic biology to their potential applications in medicine and beyond. It's a fascinating field that's sure to play a big role in the future of healthcare and scientific research.
Absolutely. And remember, if you want to learn more about stem cells or any of the topics we've discussed today, there are lots of great resources out there. Check out reputable scientific journals, university research pages, or organizations like the International Society for Stem Cell Research. Until next time, keep questioning, keep learning, and keep exploring the amazing world of science.